Okay, Chapter 4, Section 5, solving quadratic equations with degree 2, meaning squared. These are also known as quadratics. Okay, we have just finished learning how to factor quadratics. Now we're going to use factoring to solve for the X-intercepts. Okay, basically what you already know how to do is you already know how to factor, which is these 3 steps here. Okay, what we are adding today is we are adding the equation part of it. Steps 1, 5, 6, and 7. Okay, and basically what we're going to do is first thing before you even start to solve the equation, you're going to set it equal to 0, which is step 1. Then you're going to factor just like you normally did in Chapter 4, Section 4, which you just took a quiz over. Steps 5, 6, and 7 are also added. You're going to set the GCF in any parentheses equal to 0, solve each small equation, and these are going to be my answers, also known as my X-intercepts. What is an X-intercept? An X-intercept is a point on a graph where it crosses the X-axis. All X-intercepts are in the form x, 0, because the y value is always going to be 0 if it is an X-intercept. X-intercepts are sometimes called answers, solutions, factors, zeros, or roots. If you take a standardized test or anything like that, they might have a different name. Those are the names you might be looking for. So let's make sure and remember that way you don't miss the question just because of the vocabulary. All right, let's talk about X-intercepts really quick and what type of solutions we're going to get. If this is my graph and I have a quadratic in the shape of a U, most of the time I'm going to have 2 X-intercepts. 1, 2, okay? Which means I have 2 solutions. Sometimes, however, if the graph only hits, if the graph only hits once, let me see if I can move that down a little bit, yeah. Okay, that means I only have 1 X-intercept. And then sometimes I will have no X-intercepts. In this case, they'll be prime. They will be not factorable. So most of our problems will have X-intercepts either 2, 1, or it'll be no solution. Let's go ahead and do an example. Okay, so I have x squared minus 3x equals 28. Based on the steps that we were doing, what do I do first? Well, step 1 says set the equation equal to 0. In order to set the equation equal to 0, I have to subtract 28 from both sides first. So that leaves me with x squared minus 3x minus 28 equals 0. Then I have to factor out, just like we did in section 4.4, greatest common factor, negative. I don't have one, so I'm going to go ahead and factor like normal. I'm going to make my x. A times c is negative 28. Middle term is negative 3. I need factors of 28 that add up to 3, that add up to negative 3. So 1 and 28, 2 and 14, 4 and 7, and there they are, negative 7 and positive 4. X minus 7, x plus 4. Now I have to think, okay, that's how far we got before, but think to yourself, okay, anytime you have in this case, 2 binomials multiplied, what do we know about any 2 numbers that multiply together in order to get 0? Okay, if I had a times b equals 0, what do you know about a and b? One or the other has to be equal to 0. Same is true here. This or this has to be equal to 0 in order for this to be true. So I'm just going to set x minus 7 equal to 0 and x plus 4 equal to 0. Solve both. And then I have x equals 7, subtract 4, x equals negative 4. Those are my X-intercepts. So in this case, I have 2 X-intercepts. If the question says place your X-intercepts as an ordered pair, make sure you put them in 7, 0 and negative 4, 0. It just depends what the question asks. Let's try another one. Step 1, set the equation equal to 0. So I'm going to subtract 10 from both sides. I'm left with 3x squared minus 13x minus 10 equals 0. Greatest common factor, negative. I don't have one. So I'm going to go ahead and make my x. 3 times negative 10 is negative 30. That adds up to negative 13. So I have 30 here. I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. For this one, it's going to be negative 15 and positive 2. It can't be this one because they both have to be negative, and that would give me a positive 30. So I'm going to pick 2 and negative 15. So I have x plus 2 and x minus 15. Since I have an a value this time, I have to divide by that a value. So divide by 3, and simplify if possible. This one does not simplify, so the 3 comes out in front. So I have 3x plus 2. This one does simplify to 5, so I have x minus 5. In order for this to be true, 3x plus 2 equals 0 or x minus 5 equals 0. So set them both equal to 0. So 3x equals negative 2 over divide by 3, x equals negative 2/3. Most tests will want you to leave it as a fraction instead of a decimal. Add 5. I want you to leave all of my examples that I give as a fraction. So x equals 5. So those are my two x-intercepts. 4x squared minus 35x minus 9. Greatest common factor, negative out in front. I don't have any, so I'm going to go ahead and solve. 4 times negative 9 is negative 36. That adds up to negative 35. I know this one right away because I know it has to be 1 and 36. So I'm just not going to write the rest. Okay, 1 and negative 36 multiply to negative 36, but they add to negative 35. So I have x plus 1 and x minus 36. I have that a value, so I have to divide by 4. That one does not simplify, so my 4 comes out in front. So I have 4x plus 1. 36 divided by 4 does simplify. It's 9, so I have x minus 9. To solve, what does 4x plus 1 have to equal? 0, and x minus 9 has to equal 0. Subtract 1, divide by 4. X equals negative 1/4. There's one answer. Add 9. X equals 9 is the other answer. So there's both of my x-intercepts. All right, 16x squared equals 49. Set the equation equal to 0 first. This one's not set equal to 0, so I have to subtract 49 from both sides. So it's going to be 16x squared minus 49 equals 0. And if you notice, I do not have a middle term here, but I do have two perfect squares that are separated by a subtraction sign. And if you remember, that's a special case. Two perfect squares separated by a subtraction sign means that I can take the square root of the first one plus the square root of the second one, square root of the first one, minus the square root of the second one, because the middle term is going to cancel out, and that will happen if you do this. Square root of 16x squared is 4x plus 7, 4x minus 7. And now set them both equal to 0 and solve. So 4x plus 7 equals 0, and 4x minus 7 equals 0. Subtract 7, 4x equals negative 7, divide by 4, x equals negative 7/4, leave it as that fraction, improper fraction. And this one, add 7, so 4x equals 7, divide by 4, x equals 7/4. Leave it as an improper fraction. Let's try another one. Now I have 10x squared equals 9x. For this one, I have to set it equal to 0 again first, so I'm going to subtract 9x from both sides. So I have 10x squared minus 9x equals 0. Look for a greatest common factor. Now, the more common thing is to think, well, 10 and 9 don't have a greatest common factor, and you'd be right. However, they both have an x, so I'm going to factor out an x for each term. 10x squared divided by x is just going to be 10. Oops. They don't both cancel. One x cancels, so I'm just left with 10x. Both of these x's cancel. Minus 9 equals 0. If you were to factor that x back into the equation or into the expression, you would get 10x squared minus 9x, which is what we want. It's just the distributive property backwards. Now, what would have to be true in order for this equation to equal 0? This has to equal 0, or this has to equal 0. The first term, x equals 0. If x would equal 0, that would cancel out the 10x minus 9. If 10x minus 9 equals 0, that would also work. So I have to solve that one. Add 9, divide by 10. X equals 9/10. So that still has two answers. We just solved it a little bit different. We'll do a couple more examples. X squared minus 12x plus 27 equals 0. This one is already solved and set equal to 0, so let's go ahead and factor that. Greatest common factor I don't have. However, let's see if we can factor it. I have 27 and negative 12. A times C goes up here, B goes in the bottom. Factors of 27 that add up to negative 12, so 1 and 27, 3 and 9. There they are, negative 3, negative 9. So I have x minus 3 and x minus 9. I do not need to divide since my a value is 1. So x minus 3 equals 0. X minus 9 equals 0. Add 3. X equals 3. Add 9. X equals 9. This one's a little trickier because the numbers are larger. So let's go ahead and solve. I have already set the equation equal to 0. It's given to me set equal to 0. So let's go ahead and factor out a greatest common factor. I don't have a greatest common factor because I have a 19. 19 is a prime number, meaning it's divisible by only 1 and 19. So we don't have a greatest common factor. So we're going to have to deal with the big numbers, which is fine. So 15 times 6 is 90, and then that adds up to 19. And if you think about it, you might guess what they are. If not, make sure you run over to your factor finder and look. I already did. Factors of 90 that add up to 19 are 9 and 10. Okay, and you don't have to write them all out if you find them, so just write them in your box, 9 and 10. So I have x plus 9 and x plus 10. And then I have to make sure and divide by my a term. So divide by 15, divide by 15. Simplify the fraction if possible. These are both divisible by 3, so this is 3/5. Take your 5, put it out in front, it becomes 5x plus 3. 10 and 15 are both divisible by 5, which is 2 and 3. Take your 3, put it out in front, so I have 3x plus 2. Now, I'm finished factoring, so now I have to set each parenthesis equal to 0. So 5x plus 3 equals 0. And 3x plus 2 equals 0. Solve, I'm going to subtract 3. So I have 5x equals negative 3. Divide by 5. X equals negative 3/5. That's the first one. Subtract 2. So 3x equals negative 2. Divide by 3. X equals negative 2/3. Here's my two X-intercepts. Okay, we'll try one more and then we'll be done. Okay, so this one, I have 6x cubed equals 5x squared plus 6x. So this is actually not a quadratic, but we can still factor it. So let's go ahead and try it. So subtract 5x squared, subtract 6x to set it equal to 0. This side will become 0, and this side I'll have 6x cubed minus, my minus sign didn't show up, minus 5x squared minus 6x. Okay, and the reason I can do this one is because I do have a greatest common factor, okay, and it's x. I'm going to take an x term out of each one, and I'm left with 6x squared, because if I divide this by x, I'm only left with 2. If I divide this by x, I'm only left with 1. If I divide this by x, they cancel out. So minus 6 equals 0. Now I have in the parentheses, what looks normal. So I'm going to go ahead and solve that. So I have x out in front. What are my two binomials? What are factors of negative 36 that add up to negative 5? Well, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Negative 9 and positive 4. So I have x minus 9 and x plus 4. I do have an a term, so divide by 6. Divide by 3, divide by 3 would be 3. Divide by 3 would be 2, so it would be 2x minus 3. This one, divide by 2, so I have 3x plus 2. Now I'm going to have 3 intercepts, and because it's a cube, that makes sense. So it's x equals 0, 2x minus 3 equals 0, 3x plus 2 equals 0. And those are my 3 answers. This one's already solved. Plus 3 divided by 2. X equals 3 over 2. Subtract 2. 3x equals negative 2. Divide by 3. X equals negative 2/3. So I have 3 answers for that one.